Question 21. The energy required to break 1 mole of an ionic crystal into its isolated gaseous ions is A. Atomization energy, B. Sublimation energy, C. Lattice energy, D. Enthalpy of formation. The correct answer is C. Lattice energy. Explanation. Lattice energy refers to the energy needed to separate 1 mole of an ionic solid into gaseous ions. Question 22. What is the correct sequence for the processes occurring in the mass spectrometer? A. Vaporization, ionization, acceleration, deflection. B. Ionization, vaporization, deflection, acceleration. C. Ionization, vaporization, acceleration, deflection. D. Vaporization, acceleration, ionization, deflection. The correct answer is A. Vaporization, ionization, acceleration, and deflection. Explanation. The correct sequence is vaporization, ionization, acceleration, and deflection. This ensures that the sample is properly ionized and separated for detection. 23. The oxidation number of ion in the compound Na₃Fe open parenthesis Cn close parenthesis 6 is A. 2 plus, B. 5 plus, C. 4 plus, D. 3 plus. The correct answer is D. 3 plus. For the compound Na₃FeCN6, sodium is +1, so we have 3 plus Fe. Cn is -1, so plus -6 equal to 0. It's a neutral compound, so Fe is equal to +3. 24. The mass of 1.51 times 10 to the power 23 molecules of CO2 is, take Avogadro's constant number to be 6.0 times 10 to the power 23, molar mass of CO2 to be equal to 44.0 grams per mole. A. 22.0 grams, B. 0.55 grams, C. 5.5 grams, D. 11.0 grams. The correct answer is D. 11.0 grams. Explanation. Number of molecules is equal to moles times Avogadro's constant. So to find the moles, we will divide number of molecules, which is 1.51 times 10 to the power 23 by 6.0 times 10 to the power 23. And once you get the moles, mass would be equal to moles times molar mass. So we have 0.252 times 44 grams per mole, which will give you 11.0 grams. 25. Which of the following hydroxides is amphoteric? A. Aluminium hydroxide. B. Calcium hydroxide. C. Iron hydroxide. D. Magnesium hydroxide. The correct answer is A. Aluminium hydroxide. Explanation. Aluminium hydroxide can react with both acids and bases, making it amphoteric. 26. Which observation will be made during the electrolysis of copper 2 tetraoxosulphate 6 solution using copper anode and carbon cathode? A. The anode dissolves. B. The color of the solution remains the same. C. Hydrogen ions are discharged at the cathode. D. Copper is deposited on the anode. The correct answer is A. The anode dissolves. Explanation. At the anode, copper metal oxidizes to copper 2 plus and dissolves into the solution. 27. In the presence of phenolphthalein, alkali shows A. Green color. B. Orange color. C. Violet color. D. Pink color. The correct answer is D. Pink color. Explanation. Phenolphthalein turns pink in basic, which is alkaline solution, due to its pH sensitivity. 28. Which of the following statements about a buffer solution is correct? A. It is usually a small amount of an acid. B. Addition of small amount of alkali increases the pH. C. Addition of small amount of acid reduces the pH. D. It resists a change in pH on addition of either small amount of an acid or an alkali. The correct answer is D. It resists a change in pH on addition of either small amount of an acid or an alkali. Explanation. A buffer solution maintains a relatively constant pH even when small amounts of acid or base are added. 29. Which of the following substances is added to the iron ore and cooked in the blast furnace during the extraction of an iron? A. Calcium oxide. B. Sulfur. C. Hydrogen. D. Limestone. The correct answer is D. Limestone. Explanation. Limestone, which is calcium carbonate, is added alongside iron ore, which is Fe2O3, and coke, which is carbon. Question 30. Dilution of ethanoic acid solution increases its electrical conductivity due to A. Increase in solubility. B. Decrease in solubility. C. Decrease in dissociation. D. Increase in dissociation. The correct answer is D. Increase in dissociation. Explanation. Diluting a weak acid like ethanoic acid shifts equilibrium towards more ionization, increasing conductivity.